In this section, we will explore what are nanoparticles. Nanoscience is a new and exciting area of science. The prefix nano is a unit. So, of course, you are familiar with units like milli or micro. We use milligrams or micrometers. We also have a unit which is nano. Milli means 1,000th and micro means 1 millionth. On the other hand, nano units are really small, and nano means 1,000 millionth or 1 billionth. So 1 nanometer, which is represented as 1 nm, so nanometer is nm, is equal to 1 times 10 to the power minus 9 meters. So can you imagine how small it is? So 1 nanometer is equal to 0.801 meter. So nanoscience is the science of really tiny things. Scientists need a scale to use when referring to tiny particles. The sizes of nanoparticles are quoted in nanometers. On the other hand, the size of larger particles in the air is quoted using micrometers. Remember that micro is 10 to the power minus 6, so 1 micrometer is 1 times 10 to the power minus 6 meters. These particles in air are often pollutants, pollen, or dust, and they are known as particulate matter. So we will use particulate matter, PM, to refer to particles in the air. This figure over here shows the size of different types of particles. Nanoparticles are particles whose size is between 1 and 100 nanometers. Particles with a diameter of 10 micrometer are known as PM10, and these are classified as coarse particles, and they are referred to as dust. On the other hand, fine particles have a smaller diameter of between 0.1 micrometer and 2.5 micrometer, and they are described as PM 0.1 to PM 25. So nanoparticles are 100 times smaller than even the finest dust. So here we have nanoparticles. They are even smaller than fine particles and coarse particles, which is dust. Actually, materials will behave very differently when they are on a very tiny scale with sizes under 100 nanometers. When nanotechnologists arrange atoms and molecules to make particles on a nanoscale, the properties will be truly remarkable. Let's find why. Actually, this happens because nanoparticles have a huge proportion of their atoms or molecules at the surface of the particle. To understand this more, we will investigate the surface area to volume ratio. So we will divide the surface area over the volume. The higher the ratio, the greater the proportion of particles exposed at the surface. So let's take these 3 cubes. The surface area of this whole cube is 100 times 100 times 6 centimeters square, which is equal to 60,000 centimeters square. The volume is 100 times 100 times 100, which is equal to 1 times 10 to the power 6 centimeter cube. Let's now find the surface area to volume ratio. We will divide the surface area by the volume, and this is equal to 0.06 per centimeter. If we take a smaller cube where the length of the side is 10, we will find that the surface area to volume ratio is 0.6, so it's bigger. Even a smaller cube where the length of the side is 1 centimeter has a surface area to volume ratio of 6 per centimeter. So we can conclude that as the side of a cube decreases in size by a factor of 10, its surface area to volume ratio increases by 10. So the higher the ratio, the greater the proportion of particles exposed at the surface. And this makes nanoparticles highly reactive compared to even powdered reactants. So, because nanoparticles are more reactive than materials with normal particle sizes, this will result in a more sustainable approach in industry because less resources will be used up